In 1997, a French woman named Jeanne Calment passed away after 122 years and 164 days on this earth, making her the oldest known person in history. Her age was so astounding that a millionaire pledged $1 million to anyone who could break her record. But in reality, living to this age or beyond is a feat that very few, maybe even no humans, are likely to accomplish. Human bodies just aren't built for extreme aging. Our capacity is set at about 90 years. But what does aging really mean, and how does it counteract the body's efforts to stay alive? We know intuitively what it means to age. For some, it means growing up, while for others, it's growing old. Yet finding a strict scientific definition of aging is a challenge. What we can say is that aging occurs when intrinsic processes and interactions with the environment, like sunlight and toxins in the air, water, and our diets, cause changes in the structure and function of the body's molecules and cells. Those changes in turn drive their decline and subsequently the failure of the whole organism. The exact mechanisms of aging are poorly understood, but recently scientists have identified 9 physiological traits, ranging from genetic changes to alterations in a cell's regenerative ability, that play a central role.
One of the most important principles of Einstein's general relativity is the equivalence principle. It says that all objects, regardless of their mass and composition, would accelerate in the same manner in the same gravitational field when no external forces act upon them. Confused? Let me put it in simple words. Suppose you simultaneously drop a feather and a stone towards the ground from the same height in a perfectly resistance-less environment. Which one, according to you, will touch the ground first? One may think that as a stone is more massive than a fragile feather, it should experience more gravitational force and hit the ground first. But that's not the case, because as per the principle of equivalence, both objects should fall simultaneously on the ground. In other words, one can say that the inertial and gravitational mass of a body is proportional to each other, which makes the acceleration independent of the physical nature of the body. Now, what is the difference between inertial mass and gravitational mass? The mass that appears in Newton's second law of motion is termed inertial mass. It simply describes how difficult it is to accelerate an object. On the other hand, the mass that appears in Newton's universal law of gravitation is the gravitational mass. It depicts the strength with which gravity acts on a body. So although a stone has more gravitational mass than a feather, the force of gravity acting on it is greater. At the same time, its inertial mass is also greater, which makes it difficult to accelerate. So the two effects cancel out, and it falls with the same acceleration as that of the feather, which is precisely the value of acceleration due to gravity in free fall. No matter how small, if there's any violation in the proportionality between inertial and gravitational mass, Einstein's entire system breaks down.
Glaucon breaks all good things into 3 classes. The first kinds we desire for their own sake, like the experience of harmless pleasure. The second we want only for the value they bring, though they may be onerous, like exercise or medicine. The third class comprises things we desire for their own sake and the value they offer, like knowledge and health. Glaucon argues that justice belongs to the second class of good. It's a burden that nevertheless brings rewards. The only reason anyone conducts themselves virtuously, he reasons, is due to external influences. So it's appearing, not actually being, virtuous that matters. Socrates, as written by Plato, disagrees, countering that justice belongs to the third class of good, offering both extrinsic and intrinsic benefits. Socrates argues that the human soul has 3 parts: reason, spirit, and appetite. Reason guides an individual to truth and knowledge and is influenced by either spirit or appetite. Spirit is righteous, ambitious, and the source of bold action, while appetite consists of baser, bodily desires. To Socrates, the philosopher is led by reason, and their spirit keeps their appetite in check, making them the most just and the happiest. Even without consequences for self-serving wrongdoings, they wouldn't commit them. Meanwhile, the tyrant succumbs to appetite and acts unjustly.
A lot of people can't get used to the short days or longer nights during the winter months. There's a lot of theories as to why that occurs. One of the theories is that we became desynchronized with the light-dark patterns because we don't get enough light during the day. So some people can't really adapt to that. So they start having feelings like depression, withdrawal, carbohydrate craving, weight gain. And that typically goes away during the summer months. So that's really what characterizes what we call seasonal affective disorder, known as winter blues.
I think there are huge individual differences. But we know of studies where it appears that maybe 20 minutes of daily dosage of strong light is enough. And then we're talking about a light that resembles daylight or an outdoor exposure. And this light dosage should be presented during morning hours.
There's a couple of things that can be done. Well, first of all, obviously go outdoors during the day. If you can, spend 1 to 2 hours outside. If you can't do that, sit by a window. But don't sit against the window. Sit facing the window, because that's where you want to get the light. You wanted the light at the eye. And the third option is increase the amount of light that you have around you. So if you're going to sit at a desk and work from home, add table lamps, add lamps around your computer screen, add something that would increase that amount of light at the eye.
Radiation is a word that makes people very nervous, but to radiate just means giving off. Like when the radiator in your house gives off heat in the form of infrared radiation. Different parts of the electromagnetic spectrum correspond to different types of radiation, and many of them are perfectly harmless. Some of them can be dangerous though. Radiation with very short wavelengths, like UV light, X-rays and gamma rays, are strong enough to rip electrons out of their atoms, which can cause burns and genetic damage. This is what many people have in mind when they hear the term radiation. The rest of the spectrum covers a large range of longer waves, from visible light, infrared, microwaves to radio waves. This is the kind of radiation that's emitted by all sorts of human technology, mobile phones, Wi-Fi routers, electric power lines, and household appliances. This radiation doesn't disrupt molecules in our body. However, some kinds of radiation can stimulate muscles and nerves and can also make the hair on your body vibrate, which can sometimes cause a tingly feeling above certain threshold values. Other kinds are useful for making dinner. Microwaves push the water molecules in your food around, which warms it up. This happens to us all the time. For example, the pleasant warmth you feel at the beach is your skin heating up from exposure to electromagnetic infrared radiation from the sun. We are surrounded by natural and generally harmless sources of electromagnetic radiation all the time, and always have been.